welcome back to the third episode of A Timeline of COVID-19. I'm joined here today with our guest Saige, who has also participated in last episode's podcast about some of the more common symptoms of COVID.
I heard we're going to go into some more severe responses to COVID-19.
Exactly. We have some rather brutal symptoms to dish out today. What do you know about strokes?
I know that it's related to the heart and the brain, but not much else besides that.
A stroke is a condition where blood flow to the brain is stopped. Now, would you be surprised if I said that strokes could actually be seen in COVID-19 patients? COVID, as we know, creates inflammation in the body. However, it also causes hypercoagulation of the blood due to the immune system releasing autoantibodies.
What does that mean?
Well, I'm glad you asked. Hypercoagulation is the rapid and increased formation of blood clots in blood vessels like arteries, veins, and capillaries. With the increased formation of blood clots, there is also an increased risk for stroke, as blood clots can block the flow of blood to the brain. This is why an estimated 1/3 of patients hospitalized from severe COVID-19 develop complications related to blood clotting, such as stroke, according to Baltaziak's article on the topic.
Wow, that's really interesting and honestly frightening. Is there any way to treat it?
Blood clot formation occurs when a plasma protein, fibrinogen, is converted by an enzyme called thrombin into another protein, fibrin. This fibrin adheres to the platelets in the blood and creates an insoluble clot. Usually, emergency IV medication is given that can break down this clot. An example of one of them is TPA. TPA is also known as a tissue plasminogen activator and is a serine protease enzyme.
Oh, I know about this too. So like most enzymes, it needs a substrate in order to activate. The substrate in this circumstance is the fibrin on the blood clot surface.
Exactly. This in turn converts the plasminogen attached to the fibrin into plasmin. This plasmin created will then cleave the blood clot. Now that we're talking about the brain, it reminds me of another rare condition, Guillain-Barré syndrome.
Right, let's talk about that.
Guillain-Barré syndrome is a neurological disorder where your immune system attacks the peripheral nervous system, the communication system between the central nervous system and the rest of your body.
That sounds quite scary.
It really is. It's quite severe and only starts to appear after 1 to 4 weeks after infection. Luckily, though, it is rarely displayed in cases of COVID and only most commonly appears in severe cases of COVID in males around age 50, according to Mehta's and Sunder's 2021 research paper on the condition.
Lucky us, I guess. So does this condition only appear in COVID?
No, actually. Other places GBS commonly appears is in Epstein-Barr infections, much like in mono, and other influenza, like strain A and Haemophilus. Do you want to explain how it works?
Sure. The immune system starts to attack and destroy the myelin sheath on the axons of your neurons. Do you know what would start to happen?
Well, the myelin sheath on neurons helps the conduction of electrical signals to the brain, so it would decrease or stop the spread of that signal?
You hit it right on the nail. Because of the damage to the myelin sheath, neurons are unable to send signals to the body efficiently, so your muscles can no longer respond to the brain's commands as easily. In addition, the brain also receives fewer signals from the body, like pain and heat.
Right. Because myelin is a membrane that is very high in lipid content and surrounds the body's neurons, and because of its high lipid content, which is even higher than in plasma membranes and cells, the nonpolar hydrophobic interactions between the myelin and the polar hydrophilic cytosol and extracellular fluid forces the myelin to spontaneously form tightly with itself into a membrane.
Oh, so that's how the myelin is able to conduct so well. It's basically an insulator for the neuron itself. It's so tightly packed together and it's high in lipid content, so the electrical conduction can just glide on it.
Correct.
So all of this means that GBS attributes to muscle weakness in COVID patients.
Exactly. It also attributes to the tingling, pain, or any other sensation changes in the body.
This is really interesting, but why does the immune system start to attack your own body?
This in itself is a question that's also debatable in the research world. From what I've seen, the main theory is molecular mimicry.
I guess not everything is known in science.
Yeah, molecular mimicry is hypothesized in research to be the cause of GBS, as some of the molecules in the myelin sheath are similar to, and therefore, quote-unquote, mimic the molecules of the coronavirus.
Oh, wait, so wouldn't your white blood cells confuse the molecules in the myelin for the coronavirus?
That is the exact problem. While the white blood cells in your body are trying to do their job in attacking the virus, it mistakenly attacks the myelin sheath on your neurons. This is because your T and B lymphocytes start producing antibodies for the coronavirus, but that also means it's starting to produce antibodies against your own myelin.
Wait, so that would make macrophages attack COVID's antigens and also the myelin sheath surface antigens. That's interesting, but why is it the most common theory?
Several reasons point back to molecular mimicry. Some of these include the delayed muscle weakness in limbs in the body after infection and the presence of autoantibodies making the immune system try to attack its own body. However, not all cases of COVID-19 and Guillain-Barré syndrome detected autoantibodies, so there is still a debate on whether molecular mimicry can be the actual cause.
So what could it be?
Instead of molecular mimicry, it could just be due to a parainfection mechanism due to generalized hyperinflammatory response, according to Mehta and Sunder's 2021 article on the topic.
Wow, we really went into a lot about the more serious and rare symptoms of COVID-19 in this episode. Quite scary, honestly.
Yeah, but it's still interesting to talk about.
Definitely.
Well, thank you all for joining us for the third episode of A Timeline of COVID-19, and a special thanks to Saige, our guest for today. Next episode, there will be an in-depth talk on a post-COVID symptom, sepsis.